Hello everyone, and welcome to the study guide lesson, Compute with Scientific Notation. It's lesson 4-5 on page 83. As always, we're going to list 1 or 2 points right here about the lesson. And we know that one of the things we're working with when we compute is we're going to multiply and divide scientific notation, as well as subtract and add scientific notations. Please copy down multiplication and division with scientific notation and addition and subtraction with scientific notation. Let's look at a quick review on the side. For a key answer, name the property represented by the sentence below. 6 plus 3 plus 4 is the same as 6 plus 4 plus 3. So we change the order around, but it doesn't change the sum. So 6 plus 4 is 10 plus 3 is 13. 6 plus 4 is 10 plus 3 is 13. It does not change the sum. What do we call this property? It's the commutative property of addition. It doesn't actually work with subtraction. It only works with addition. The commutative property. If it were multiplication, what would we call it? If you're thinking associative, you are correct. On the last lesson, I asked you, or I said if you wanted to, you could Google the blackbird and see how fast it actually travels when they say Mach 3. Well, I hope you did, so that you can see some neat stuff. Here we have the SR-71 Blackbird is one of the world's fastest airplanes. It is capable of traveling at a cruising speed of Mach 3 and 3 times the speed of sound. The speed of sound is approximately 760 miles per hour. So 3 times this speed, boys and girls, this rate. Express 760 in scientific notation. So remember that we have to put the 7 in the ones place and then account for the 2 place value in the base of 10. So it would be 7.6 times 10 to the square, 10 times 10 squared, or 10 to the second power, which is 100. So 7.6 times 100 will move the decimal place over twice to give you 760. Suppose the SR-71 Blackbird travel 150 hours in 1 month. Express 150 hours in 1 month. Express 150 in scientific notation. Well, 150 would be simple. We take again the first number and put it in the ones place. So it would become 1.5 times 10 squared, right? Times 100. Number 3. Write a multiplication expression using the numbers in exercises 1 and 2, so what we did up here, okay, to represent the total number of miles traveled by the SR-71 Blackbird in 1 month. So we traveled 150 hours in 1 month at the rate of 760 miles per hour. So this times 150, right? That times 150. Well, but they want us to use scientific notation, right? Using the numbers that so we're simply going to take our first value, which is the rate, the speed, 760 miles per hour, okay, 760 as written scientific notation, times our 150 written in scientific notation as well. This will tell us how far the blackbird traveled. For example, 760 times 150 hours, 760 per hour. Question 4. You can use the commutative and associative properties of multiplication to rewrite the expression in exercise 3. Yes, we can. I know that this one can be multiplied with this value. 7.6 times 1.5 can be grouped. Okay, associative property of multiplication. And 10 squared can be grouped with 10 squared, as you see it right there. Okay? Fill in the boxes to write an equivalent expression with 1 power of 10. Well, with 1 power of 10, remember that when we multiply right there, okay, when we multiply base 10 with an exponent, we simply just add the exponent, so it would be 4, 10 to the power of 4. And now we must multiply 7.6 times 1.5. And when we do that, we will get 11.4. There you have it. That's 11.4 times 10 to the 4th power. That is how far it would travel in 150 hours. And now they want us to solve this. They want us to write the product in exercise 4 in both scientific notation, so here's our scientific notation, and standard notation. Well, scientific notation is 11.4 times 10 to the 4th power, right? And I'm going to write 114, and it's traveling, it's going 1 plus 3 more. So it's 1, 2, 3. So I have to, okay, that's 2 jumps, that's 3 jumps, that's 4 jumps. So the decimal place jumps 4 times. I'm going to put a comma there, an exaggerated comma, and that is 114,000 kilometers, right? Okay, on the next page, which is page 84, we're going to continue practicing. And here we have, for each product, fill in the boxes to show how you would apply the commutative and associative property. Okay, let's group the decimals. So we have, let me zoom this even more. And we have 1.5 times 6.2, and 10 to the power of 5 times 10 to the power of 3. Okay, and when I actually, there it is, that's done. Now let's do number 2. For number 2, we actually have to solve. Remember that when we, whoa, that's an accident. That when we actually have a division, we subtract the exponents, and we have to divide these two numbers together. And you should have something that looks like this when you use the associative property, when you apply the associative property. Number 3. How do you divide two numbers written in scientific notation? Well, so how do I divide this? Well, first, I have to divide the factors, don't I? Okay, I have to divide these two factors right here. And then I have to subtract the exponents in this parentheses. Divide the factors and subtract the exponents. There you have it. Please copy this down. This is a key answer. You put a star right there and a star right there. Okay, now let's try adding. For each expression, circle a number that you would rewrite in order to add or subtract. Then rewrite the numbers so that both numbers have the same exponent. Okay, so here we have 8.393 times 10 to the 5th power plus 7.12 times 10 to the 4th power. Okay, if I were to, for example, move this decimal to the left, that means this would go up to 10.5, right? Because then when I multiply it, by 10 to the power 5, it'll send it right back one more time, and then it'll send it the 4 times that I wanted it, so it can be the original number. Okay. I can do that vice versa with this one. I can go, if I were to go down to 10 to the power of 4, okay, so I can match this one here, this decimal would have to move once to the right. Does that make sense? Make sure that this makes sense to you and that you're memorizing this. So which one are we going to do? I think for the sake of working with whole numbers, let's do that. Let's put this one down to 10 to the power of 4, right? And let's move this guy over to the right so that he becomes 89.3. Okay? So we're going to change that one to 89.3 times 10 to the power of 4, and now we can work with both. We can work with both of them. I can now add this 7 to the 9 and this decimal 12 to decimal 30 over here, and then we keep the same exponent, 10 to the power of 4. Do you see that? Okay, let's try 5 and 6. If we were to work with the next one, okay, we would have, now remember, you can change this number right here to the standard notation and see what number it really is, and then you just work with just standard notation. You subtract this number from this number when they're both standard notation. But what you could do is count how many number places are here. For example, we have 1, 2, 3, 4, 5, 6, 7. So this one is 10 to the 7th power, right? But we can make it 10 to the 5th power if we get rid of, let me see, if we get rid of this jump and we get rid of this jump, right? If we get rid of both of those jumps, then it would be 10 to the 5th power. So it would actually, the number would be 124.3 times 10 to the, let's see, 1, 2, 3, 4, 5 times 10 to the 5th power. So yeah, it works, right? So let's do that. Let's do 124.3 times 10 to the 5th power. Okay, number 6. If you're feeling confident, try this one on your own. Pause the video and try this on your own. If not, then continue along with me. Okay, so we have, let's say, if I were to make the scientific notation, I have 1, 2, 3, 4, 5. Okay, 10 to the 5 times 10 to the 5th power. And here I have to the 6th power. Now, I could keep it at the 6th power here and make this 0.529 times 10 to the 6th power, so that I know that I'm only adding this part to the decimal, you see, so that it can make it equal. So yes, 0.529 times 10 to the 6th power. Okay, that's all for today, boys and girls. Actually, no, that's not all yet. Please complete the summary. Write 2 sentences to summarize the lesson. You multiply and divide scientific notations. You add it and subtract the scientific notation. You could even put a comment on there of what helps you remember how to add or subtract scientific notation, associative, commutative properties, or so on. Okay.